right, welcome into Chapter 3, Section 3. Today we're going to be talking about graphing equations in slope, intercept, point slope, and standard form. Slope, intercept, you're probably used to seeing. Point slope might be a little bit new, and standard form might be completely new, but it's not nearly as difficult as it might look, and we'll teach you some shortcuts on that. Graphing in slope-intercept form, right, is probably what y'all are most used to seeing. It's that go-to, I don't know the answer, so it's y equals mx plus b, okay? And you remember that m represents your slope, and b represents your y-intercept. Now, just make sure, right, that we understand your y-intercept is where your function crosses the y-axis, okay? Not crossed, crosses. There we go. It's where your function crosses the y-axis, and I'll show you guys some examples here in just a second. But a lot of times there's confusion on, okay, what does y-intercept mean? It's just where it crosses the y, okay? There's three main steps, okay? First thing, I'm going to plot the y-intercept. You're always going to start with your b value. Next, I'm going to use the slope to find the other points. And then three, I'm going to connect those points with a line. Okay, so given these, okay, we want to identify my slope and my y-intercept, right? So all of these are already in y equals mx plus b. Okay, so I'm just going to make sure I'll highlight my m in orange and my y-intercept in pink. Okay, so looking here, if I'm looking at this first example, my slope is 4/5 and my y-intercept is positive 5. So what I'm going to do is I'm going to start on positive 5 on the y-axis. So we have to make sure we understand, okay, this is my x, right? X is left and right, and this is my y. If you're ever confused on which axis is which, the y almost makes a vertical, right? That's how I always remembered it. Y kind of makes an up and down. So on my y-axis, I'm going to start at positive 5. So we start from your origin. You always start from your origin. We go up 1, 2, 3, 4, 5. Okay, let me make that a little bit bigger point. That might help. A little bit bigger. Okay, so we start at 5. And then I use my slope, which is 4/5. And you remember from our earlier lesson, slope is just rise over run. So from this point, I'm going to go up 4, right? Because that's my top. So up 1, 2, 3, 4, and then over 5. So 1, 2, 3, 4, 5. Okay, so that is my second point. Okay, you can also go the other direction. If this is up 4 and to the right 5, then it could also work going down 4, 1, 2, 3, 4, and then to the left 5, 1, 2, 3, 4, 5. Okay, really you only need technically 2 points, but the more points that you can fit on the graph, the better, and the more accurate your graph is actually going to be. So even here I could go down another 4, 1, 2, 3, 4, and then to the left 5, 1, 2, 3, 4, 5. Okay, and then from there I can connect my graph using a line, right? We can move this out this way. So that's what the graph y equals 4 over 5 x plus 5 would look like. Okay, on this one, okay, we do the same thing. We start at my y-intercept, okay, at -2, so I can go -1, -2. Okay, we'll put a point there. Okay, and then we'll use my slope of -3. Really what that is saying is -3 over 1, right? So that means I'll go down 3, so 1, 2, 3, to the right 1. Okay, and I'll continue doing that. Down 3, 1, 2, 3, to the right 1. Or you could go up 3, 1, 2, 3, to the left 1. 1, 2, 3, to the left 1. And then your final step would be to connect those points and boom. Easy peasy. That's probably something you've done before in the past. So hopefully that's just a little bit of recall. But that's pretty much all you got to do. Graph your y-intercept, use your slope to find the other points, then connect your points. So graphing point slope is a little bit different from graphing slope-intercept, but it's really not too difficult. M still represents our slope. And then the only difference is that they have this extra point in here of x1, y1, okay? And so they give you that as your quote-unquote starting point. Instead of giving you your y-intercept, you're going to start from the point that they give you on the graph, where m is still your slope there. Okay, to graph these, okay, you are simply going to plot the point that they give you, and then use the slope to find your other points. Then once you have that done, you're going to connect your points. Okay, or alternatively, if you're like a big slope-intercept person, you can always solve for y and then graph from slope-intercept form. So say you're given this point here, right? We can identify, hey, I have my slope of 2/3, and then I have this point of 4 and 8. Now, if you look at our base, right, that said y minus y1, right? If it's minus, you're going to keep it the same. If it's negative, right, or if it's plus, that would mean that you had plugged in like minus -4, right, or something like that. That would give you +4 in your equation. So looking here, where I have -8, that means that my y value for my point is 8, and my x value for this point is 4. It's always going to appear to be the opposite of the sign, although in reality it's not. We're just subtracting that number. Okay, so we can start at that point. We can go to 4, 1, 2, 3, 4, and then 8, 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to start from, oops, that was kind of an awkward thing. So let's go back. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we'll start from there. And my slope is 2/3, so I'll go up 2 over 3. So up 2 over 3. Okay, or, and then if I run out of space, I'll have to go down 2 to the left 3. Okay, down 2 to the left 3. And you want to graph as many as you can. I'm just, for the sake of shortening this video, I'm going to not graph all of them. And as you can see, it would be like an awkward y-intercept to put there. So it's better to just start from this point and graph from there. What you could also do is solve for y. So to solve for y, all you're going to do is distribute this 3. Okay, so it becomes 3x plus 3. You've got y plus 1 over here. You can subtract 1 to get rid of it. So your equation ends up being y equals 3x plus 2. Okay, and then just like the one from before, right? You have your y-intercept, so we go to plus 2. Okay, put that there. My slope is 3, so I can go up 3 over 1, up 3 over 1, up 3 over 1, or down 3 to the left 1. And then we can connect our points and be good to go. Okay, so 2 different ways to graph point slope. Sometimes this is preferable. Sometimes this might be easier for you. The only problem with sometimes you get like a really weird y-intercept, like a y-intercept with like 5/8. So that could be a problem. But this will always work for point slope as well. Okay, for standard form, that's when it's written as ax plus by equals c. It looks really scary, but it's really not bad. So what ends up happening is you would have something like 8x minus 3y equals 10, or x plus 5y equals -5. Okay, and there's 2 main ways you could graph these. Okay, you could find the x, whoops, I guess that's not going to move. That's okay. I'll write it. So you could find the x-intercept and the y-intercept. Okay. You would plot the 2 points, and then you would connect your points. And these are really, really easy to do, right? And I'll talk about the mathematical way and then like the shortcut way I would do it. The other example you could do, right, is solve for y and then graph from slope-intercept form. Okay, that's always an option on pretty much any of these. If you, when in doubt, turn it into slope-intercept form and graph it from there. Okay, if I'm looking here, right, this x-intercept is where it crosses the x-axis, the y-intercept is where it crosses the y. So this x-intercept is really this point, -2, 0. And this y-intercept is 0, +2. So if you take a look at those points, right, what do we notice about the y-intercept of your x-intercept? Oh, or the y value of your x-intercept is always 0. The x value of your y-intercept is always 0. Okay? So to find your x and y intercepts, all you have to do is plug in 0 for the opposite variable. Okay, so looking here, actually let me go back and show you on these examples so that makes a little bit more sense. Okay, and I'm going to show you on this second example because it works out a little bit better. So we'll pretend like this doesn't exist for now. Okay, so if I wanted to find my x-intercept, okay, if I wanted to find my x-intercept, I am going to plug in 0 for y, aka I'm going to pretend it doesn't even exist, right? I'm going to give me like the most massive. Okay, so I'll pretend this doesn't even exist, right? Because it multiplied by 0, it's gone. Okay, really now what is my equation saying? X is equal to, let me make it a lot smaller, right? X is equal to -5. Okay, that would be my x-intercept. I could go on the graph and I could actually graph my x-intercept at -5. Okay, to solve for your y-intercept, you do the same thing except for you cover up the x, right? Pretend that's not there. Okay, now I have 5y equals -5. Okay, so I could subtract, or sorry, not subtract. I could divide by 5 because there's nothing over here. Divide by 5. -5 divided by 5, I would get y is equal to -1. Okay, so my y-intercept would be -1. My x-intercept would be -5. I could go graph those 2 points and connect them. Okay, I wanted to show you guys that before we actually did this example here. Okay, to do that same thing, once again, if I want to find my x-intercept, I'm going to cover up the y and pretend it's not even there. Okay, so I just go, boom, pretend that's not even there. Really, what is this saying? It's saying 2x, right? It's saying 2x is equal to 6. Well, how do I get x by itself? I divide by 2. And I'll get x is equal to 3. Okay? So on my second problem, right, if I wanted to find my y-intercept, I would cover up the x value, right? So pretend like this isn't here. Really what that's saying is that -3y is equal to 6. Divide by -3. Come on, mouse, curve, thank you. Divide by -3. And we would get y is equal to -2. Okay, so now that I have my two y-intercepts, or my two intercepts, my x-intercept and my y-intercept, I can plot those points, right? So I can go to x equals 3. So on my x-axis, I'll go to 1, 2, +3. Okay, y equals -2, so I can go to -2 on my y-axis. Bada bing, bada boom. Connect those 2 points, you're good to go. That's all you need, is 2 points to graph it. Okay, so super, super easy with standard form. Okay, if I was physically there in front of you, I would like have you cover up, right? If I'm solving for x, you cover up the y and solve for x. If you're solving for y, you cover up the x and work it that way. What you could also do is solve for y, right? So we could, let me make this small again. Subtract x over, we'd have 2y is equal to negative x plus 10. We would divide everything by 2. And we'd end up with y is equal to negative 1/2 x plus 5. Okay, and then once again from there, you have your y-intercept. You go to 5, 1, 2, 3, 4, 5. Put a point. A slope of negative 1 over 2, so I go down 1 over 2, down 1 over 2, down 1 over 2. Right, and we can connect those points there. So that's also another way that you can do standard form is just turn it into slope-intercept and work it out that way. Okay, special cases. These are your horizontal and vertical lines. We kind of use the phrase hoi vux to help us memorize it. Not necessarily that means anything. It's just kind of a silly way to remember it. Hoi stands for horizontal lines. We'll have a 0 slope. And are always y equals a number. Okay, if you ever just see y equals a number with no x's at all, that means it's going to be a horizontal line. Vux stands for vertical, an undefined slope, and x equals a number. Okay, so if you ever just see like x equals 2, that means it's going to be a vertical line. So for example here, okay, you have y equals negative 8, okay? So it's only going to go through the y-axis, so it's going to be horizontal at negative 8. So negative 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that would be a horizontal line through negative 8. Okay, if it's x equals a number, x equals 4, I go 1, 2, 3, 4. Okay, and since it's only x equals a number, it's only going to go through the x-axis, so it would be vertical line through that point. If Coach Perkins could draw a vertical line, that'd be great. Okay, so it'd be a vertical line going through 4 on the x-axis, right? 1, 2, 3, 4. Okay, so a few more practice. So looking at this, first and foremost, what form is it in? It's y equals mx plus b. Okay, so slope intercept. Okay, I would go to negative 6, 1, 2, 3, 4, 5, negative 6. My slope is negative 3 over 4, so I'd go down 3 to the right 4. Right, down 3. Oh, I'm off the graph, so I have to go up 3 to the left 4. Right, 1, 2, 3, 4. Once you have those points, you can connect them. Okay, looking at number 2, what form do we think is x equals 7? Okay, well that is going to be one of our special cases because it's just x equals a number. Because it's x, I think of hoi or vux. Vux is vertical, right? Vertical undefined x equals. So it's going to be a vertical line going through 7. So I'll go 1, 2, 3, 4, 5, 6, 7. And then it will be a vertical line going through that one. All right, we'll move this over just a little bit. Okay, vertical line going through 7. Next one we're going to look at, okay, y plus 4. If you ever see y plus or minus something on the left, that means it's going to be in point slope form. Okay, I can start by graphing it at that point. My point is 1, negative 4, right? 1, negative 4. The common mistake we see is sometimes people flip-flop these. The x is always next to the x, the y is always next to the y. Okay, so, and it's always opposite of the sign. Okay, so if this says minus 1, my point is really positive 1. If this says plus 4, it's really negative 4. So I go 1 to negative 4. Okay, what's my slope? Oh, negative 3, so I'll go from that point, I'll go down 3 over 1, down 3 over 1, or up 3 to the left 1. And I can connect those points. We'll move this slightly. So that's what my graph would look like on that one. And then my final one would be 3x minus 2y equals negative 6. This is in standard form. Okay, the first one, I pretend like the y is not there, right? I have 3x equals negative 6. You can divide by 3. We would get x equals negative 2. Okay, then the next one, to find my y-intercept, I pretend x isn't there, so I have negative 2y equals 6. Sorry, negative 6. Divide by negative 2. We'd get y equals 3. So my y-intercept is 3, so I go up to 1, 2, 3. My x-intercept, let me make that a little bit bigger. My x-intercept is negative 2, so on the x-axis I go to negative 2, and I can graph my line from there. Let me make this a little bit better. Wait, go back. The more points you have, the more accurate your line can be. But as long as you have those 2 points, you should be good to connect them. And that covers all the basics of graphing linear equations. If you have any questions or you did not understand any of these concepts, feel free to reach out to your teacher. Please let us know. We would love to help you out further. That will conclude this lesson. Hope you all have a wonderful rest of the day and have a good one.